Good morning, pilot students. Good morning, class.
Good morning, Mr.
I think you may sit down. All right, in our lessons, we have covered decay or radioactive decay, and then we also covered half-life. Right, looking at all of this, you should know what you have learned. Now, in this lesson, we'll be going through Decay series, and part of the knowledge that you gained from the last two topics will be able to help you to understand this. Right, looking at an element, right, whether it goes through, or let's say a radioisotope, when it goes through the three forms of decay, basically those two, the alpha and beta rays, what happens is that the nucleus is in an unstable state. So it will further go through decay until it comes to lead, which is more stable. So looking at this, for example, a uranium-238, which goes through decay to form thorium, and then from that it decays again further to form or come up with protactinium. So those are some examples, or that is one example of how decay series happens. So in this lesson, basically, for those pilot students who are watching, I will give you a few notes, especially on decay series, and then after that I will give you one example to complete, and from that you can draw a graph to represent the proton number and also the mass number, and then you can draw in that decay series or plot that decay series of that element. So I will show you as we go through the lesson. So quickly take out your biros and book and then have these notes down quickly. Here is the next slide. Okay, that is one example given. Okay, uranium-238, and then it goes through. So for that first one, what do you think will be the type of decay that uranium starts with? Mama. Okay, good. For uranium, it will go through alpha decay. And what about protactinium? Mary, what is the second type of decay?
Decay.
Okay, very good. It will be beta decay. That is for the second. So that is one example given to you. Until such time when the nucleus will not decay anymore, that is when it will be stable. All right, we will move on to all right, that is one example because it starts with uranium, so we have to give that a name, which is Uranium Series. Okay, if it starts with thorium, we may call it as, or we may give it a name as Thorium Series, and so forth. by now you should have finished. I'll give you the activity questions. Okay. These are your okay, you don't need to write this. Okay, the following contains the names, symbols, and also the modes of decay for this naturally occurring thorium decay series. Okay, it is a thorium decay series. Right. What I will show you now is to, especially if you can look up. After you copied those information into, right, I will ask you to have nice tables having 3 columns, and it will show you the modes of decay and the element that has gone through, or the radioisotope that has gone through decay. So after that you can plot a graph. Simply what you can plot is, all right, on the vertical axis you have the mass number, and the atomic number will run on the horizontal axis. Let's say the first example given as for uranium series. Okay, you look at those elements and then find out which will have the lowest atomic number. So you start from there, and which will have the lowest mass number. So let's say for uranium, okay, it might come to lead, which is almost about having, okay, what is the atomic number for lead? It is 82. Okay, we start with 80 over here, because, and then for uranium it starts with 92. So you plot your numbers over here, 80, 81, 82, right up to 92. And for that mass number it will be 207. Okay, you can start with 200. Okay, from that be 201 right up to this one, which is 238. So from there you put the points in. The first mode of decay would be alpha decay, so okay, and it will form thorium, which has a mass number of 234. Okay, so 234 will be somewhere there. So you look across there, 234, and in here will be 90. Okay, that is for alpha. If it still goes through that, then you still minus it or show in by indicating with these arrows. And then it goes on further until it arrives at a most stable one, which is lead. If it is bad ray or radiation that has been given off, then it will be +1. It stays the same in the mass number, but then your arrows should be facing that way to 91, and so on. Okay, so you just draw the series of that radioisotope given. So now I will give you the, okay, those are the radioisotopes, and then you have symbol and the mode of decay for each one. So quickly copy that. I'll give you 4 of these, and then after that you can start plotting this in. Right, quickly, I'll give it a second. All right, here it comes. Okay, the next would be thorium, and then you have radium, radon. Let me have a look at this. Okay, that should not be AC, but it will be Rn. Okay. Okay, this one is not AC. AC is for actinium. This one should be Rn. Okay, that is one of these. Finish?
Yes.
All right. Okay, for this one, this radioisotope, this type of decay especially, it comes with this alpha from polonium to lead, and then from lead it has to go through further decay to this. Okay, from there you find that the percentage decay for each one of these is, okay, alpha will be 34, and that is 66, okay, especially for this. So from this mode, okay, one of these will, or this one will be 66, so it goes to the next radioisotope, and this one, so it breaks up here. One has to go this way, and then you have another one which is alpha having 34%. Okay, you finished? Finished, okay. That is the last. Okay, you have polonium, thallium, and lead. Craft paper.
Lead on the bottom is in alpha, but
Should be beta.
beta.
Lead. Okay, yes.
Okay, if one of these was given, what then? It does not matter if this is given. Okay, how would your diagram look like if I have to write down this alpha? Okay, this one will be okay, PB. This one should be 2. Okay, 208. Okay, this is 208, and that is 82. And the symbol here will be PB. All right. Let me see. How did I get this one? Okay, it should be this. Did I don't know whether one of those activity questions was taken from. Maybe it's taken from this one. I just followed through. Okay, that one should be from. Okay, lead should be. Beta. Yeah. All right, just to make correction while you are here. Lead from here, it should be okay, beta decay. That is here. It is not alpha decay, beta decay. All right. If you still want to have this one, you can also try that out. But in here should be beta decay. Okay, that is for lead. All right, you can start plotting the graphs now. If you don't have a graph, just rule exactly as what I showed you. And from there you can plot the points down. Or if we have 208, is it 208? 208 and 82. That's only this one. Yeah, it's 208. Okay, you can count the number of squares, plot this one, and then one of you can plot that quickly and then you show. You just show and then you explain. Okay? Last the cameraman to. Okay, just draw quickly. Yes, draw lines and then you have a craft paper with you. Huh? Yeah, you can throw it on that. Who's got a craft paper? You don't have a craft paper? Has anyone got a paper in here? Craft paper? Any craft papers? All right, when you draw that, you have the proton here. Mesh number will be running this way. Okay, from here you find that the lowest was in here is the mesh number was 82 or 208. You can also start from 207 and then move up or 200. Okay, and here the lowest was 81. So you start from 80 and then move on this way. That is the atomic number. So if it is thorium, you follow down, that is atomic number having 90. So from 90 up to 30. And from that you write that thorium and then you plot the next one, which is this mode. And then it stays the same. You put point there. And so you roll just an arrow and next until it comes to this one. Yeah. Okay, when you draw this one, you find that the last, that is the stable one, that is having 208 and then 82. So that is the lowest number. For 81 is the lowest number. So from atomic number, starts from 80, 81 goes up this way. From here, starts from 207 and then it moves up this way. Okay, and then you plot in the first one alpha. Point, 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 and then you just draw in arrows to indicate where they go. Who doesn't know what to do?
I'm not sure what to do.
Okay, when you plot this graph, basically have the lowest number in here is lead having not lead, thallium, which is 81. So the mesh number on the horizontal axis, thallium will be, so you start from 80, 81, 82, right up to 90, 92 or 91. And then the mesh number, if you can see, 208 is the, so you start from here 207, 207, 208, and so on, 209, 210, right up to 234, which is for thorium, okay, here. And then you just get, okay, the first mode is alpha decay, so it will decrease by 4. If it decreases by 4, then it will decrease by mesh of 4. So from there, mesh of 4, 34 up here, then the next will be 30. So you look across and then you put a point there, and your atomic number decreases by 2. So it is 88. And then you look up 88 over here, 230 over here, and then put a point there, the next. And then after you have put all the points, plotted all the points in, after you've done that, you get the rule line, then you rule arrows, okay? The first arrow from thorium to radium. The second one was this mode, so there is no decrease in mass number. There was an increase in, because this particle was given off, okay? And then you just put there, okay? If that is so, there will be an increase in them, so you put it that way, okay? You just All right, if you have your craft papers, or some of you may have craft papers, you can plot the information on a craft paper, right? That information will give you a clear picture of the radioisotope that goes to decay. You started from what number? 208? Is it 208? Okay, okay. Mm-hmm.
Came down to radium. It's lost four. Four. Lost 4 electrons.
Start from the biggest and then it comes to the smallest. Okay, because decay does not start from the smallest and then go. It starts from large and then it goes down. Okay. I will go through and then show you how you can finish the rest of the questions or plotting those radioisotopes in. All right, I will start with the first two. please look up. I will explain this, and then probably some of you can give me your answers or your graphs, or show your graphs in our next lesson. All right, firstly, to quickly go through and then have a look at the first two or three decay series. Okay, thorium, that is 230. Okay, 232. 232, if it is 232, and then you look across, all right, if you use a graph paper, it will give you a nice picture. Right, looking at this, that is 232, and then what is the atomic number? 90. Okay, so you look across this. And then that is 90. So you plot your point here, and that is thorium. All right, next mode of decay will be, okay, looking at this decay, you'll find that there is no change in the mass number, but there is an increase in the atomic number. So using this, you just follow that. All right. For the first, the alpha decay, so there will be, you have to minus -4 from this mass number, and then -2 from the atomic number. So if 90 minus 2 will come up with 88, and if that is 232 minus 4 to 28. Okay. Okay. This one will be RA. Okay, there is no change because it has to go through better decay. So that is why there will be an increase in the atomic number. So the next will be somewhere around here, and then that will be, okay, actinium. Now from that actinium, it gives you better decay. So it still increases to 90, okay, plus 1. So 90 will be here. Okay, that is thorium. And you find that there is also another isotope of thorium, okay? So you can go through the rest of this decay series and then plot in the points and come up with your graph. And probably in our next lesson, okay, I might ask somebody to come up and then show your graph and then explain how you got each one of those. All right, so that brings us to the end of the lesson. All right, basically in this lesson you had a look at decay series. Once you have a radioisotope which will be going through radioactive decay, meaning that alpha and beta rays are given off, it is still radioactive, meaning that it will undergo further changes in the nucleus, and it may give off other decay as well, or forming other radioisotopes. So that is what you have just learned. Go through this. Those pilot students, you can also go through. If you have any queries, you can ask your teachers to explain. But for this activity which has been given to you, you can go through and then finish it, and we'll have a look at that in our next lesson. All right, so that brings us to the end of the lesson. Our key phrase would be Decay series. Good afternoon, pilot teachers and students. Good afternoon, class.